We're group 22 for AME 2303, Design and Manufacturing Process. Manufacturing a bracket. Some assumptions: instead of being automatically manufactured, this piece will be produced by a sheet metal worker. And the reason why we do that is to minimize cost and lead time, keep it low without sacrificing quality. Some criteria we're looking for in terms of what type of material is that the material needs to be able to deform plastically without fracturing. It needs to be strong enough to withstand normal stress without failure, and we need to consider the cost and lead time because they are factors. Initially, we thought about using thermoplastic because it is cheap and it can plastically deform without fracturing, but it's not strong enough to use. It will compromise the bracket. Using gold, silver, or copper, it is strong and it's able to deform plastically, but it costs a lot of money to use. And so we decided to go with steel, a high strength, low alloy steel. Looking at table 16.3, it has a bend radius for 4T for hard conditions. The next step is blanking. Since the whole sheet needs to be blanked, it would be best to use the process of fine blanking. This will make sure that the sheared edges are smooth, and they will also square them up. Since the clearance needed can be anywhere between 0.5 and 13 millimeters, this would be easy for the worker to estimate. Using the first equation, equation 1, the maximum force punch needed can be calculated. T is the sheet thickness and L is the total length sheared. UTS is the ultimate tensile strength of the material. The next step is piercing. The spacing between the bottom 3 holes must be proportional to each other, but also 5 times smaller than the spacing between the other holes. These other holes must be proportionate to each other as well, including the hole with several imprints around it. The punches should be done using a beveled punch, and also in order to prevent plastic bending or distortion of the metal, piercing should be done while alternating sides. The next step is drawing the metal. To minimize plastic failure, the shallowest indentation should be done first, followed by the deeper indentation. The elongated oval indentation near the hypotenuse should be done last. This should be done slowly because with all the changes done before, the piece might be weakened. In order to maintain ductility in the blank, we must use the annealing process. The last step is bending. This step prevents the material from reaching the minimum bending radius. Using equation 2, we can calculate the strain on the outer and inner fibers of the sheet during the bending process. Notice the ratio R over T decreases, the tensile strain increases, which leads to cracks. And also notice the minimum bending radius is different for each material and is much larger for hard materials. Looking at the third equation, equation 3, a graph on the side is provided to display the trend. Recapping the presentation, we are assuming to use a sheet metal worker, and also the material we decided to use is a high strength, low alloy steel. The process used to manufacture this bracket are rolling, blanking, piercing, drawing, and bending.